Welcome. In this video, we'll be taking a look at how to find the greatest common factor of two monomials. So, to begin, I want to discuss the difference between a greatest common factor and a least common multiple, because these two concepts are oftentimes confused with one another. The least common multiple is what we've been using up to this point to find least common denominators. So as an example, if I want to find the least common denominator, or least common multiple of 6 and 9, what we did was we listed the multiples of those numbers until we came across a common one. So in this case, it would have been 18. Now, why is 18 special? Well, 18 is the smallest number that when I divide this number by either one of my originals, I'm not going to get a remainder. So in other words, if I do 18 divided by 6, I get a whole number answer. And when I do 18 divided by 9, I get a whole number answer. So least common denominator is going to be the smallest number that each original can be divided into with no remainder. So how does that compare with greatest common factor? Well, again, if we go back to what factor means, remember it's the pieces that multiply together to make a number or an expression. So if I want to find the greatest common factor of 6 and 9, what I'm going to do is first find some factors that make up 6 and 9. So if I start with 6, I'm trying to think of numbers that actually multiply together to make 6. So 2 times 3 comes to mind. And I really can't go any further than this because I don't want to use 1 in my factor tree. So the smallest pieces that 6 can be broken down into is 2 times 3. Okay, if I do 9, well, 9 is broken down into 3 times 3. And again, I can't break either one of these numbers down further without using a 1, which we don't want to use in a factor tree. And so what I'm left is 9 equals 3 times 3. And so now what I'm looking for is the greatest common factor. It's the largest number, basically the largest factor that both 6 and 9 have in common. Well, in this case, notice that 6 has 1 3, and that's in common with one of the 3's for the 9. So the greatest common factor between 6 and 9 would be 3. That's the only factor that they share. So what's special about the number 3? Well, if I go back to the original numbers that we were considering, if I take either one of those numbers and divide it by 3, I'm going to end up with no remainder at all. So in other words, if I take 6 divided by 3, I get 2, which is a whole number with no remainder. And if I do 9 divided by 3, I get 3, which is again a whole number with no remainder. And so my greatest common factor is the largest number that divides evenly into both of my originals. And so the GCF is the largest, I'm going to say term, that divides evenly into the originals. Okay, so now let's see how we can apply that. So what we're supposed to do is, for number 1, we're supposed to find the greatest common factor of 11w to the third and 8n to the fourth. I'm going to skip number 1, and we're going to come back to this one for a second, because I'm going to go on to number 2. I think this is a more typical example. So number 2 is find the greatest common factor of 15n to the fourth and 12w to the third. So there's really 2 steps in the process. The first step is to look at the coefficients, or the numbers. So step 1 is to find the GCF of the coefficients, or numbers. So what I'm considering here is the 15 and the 12. Just the numbers that are being multiplied by our variables. So if I consider those 2 numbers, I'm trying to find the largest number that divides evenly into both 15 and 12. So you have to think of a number that divides evenly into 15 and 12. And I think the largest number that's going to work for both of those is 3. Okay, if I take 15 divided by 3, that's 5. If I do 12 divided by 3, that's 4. And I don't think a bigger number than 3 is going to work. So then step 2 of the process is to find the GCF of the variables. Well, here I've got n to the fourth, and I've got w to the third. Well, n to the fourth means I have 4 factors of n, and w to the third means I have 3 factors of w. Well, clearly here, none of the factors for this first expression match any of the factors over here. So their greatest common factor is just 1. If you see nothing in common, that just means automatically the greatest common factor is just going to be 1. Because 1 is a factor of anything. I can take anything divided by 1 and get an answer without a remainder. So, to finish the process, step 3 of the process is just to multiply these 2 GCFs together. So step 3, which I'm going to write down here, is multiply step 1 and step 2. So overall, our GCF is going to be 3 times 1, which is 3. Okay, let's take a look at number 3 and see if we can figure that one out. So following the steps, the first step is I'm going to find the GCF of the numbers. So here I've got 25 and 20. And again, I'm trying to think of the largest number that divides evenly into 20 and 25. Well, the largest number that's going to go evenly into both of those is going to be 5. Step 2 then is to find the GCF of our variables. So our variable parts here are x to the third and x to the first. So if I look at what these guys have in common, x to the third is x times x times x. X to the first is just 1x. So what I see that they have in common is just a single x. So that means the GCF for the variables is just a single x. Okay, I can't do more than 1x because this second guy only has 1x to share. So even though the first one has 3 x's, 3 factors of x, the problem is the second guy only really has 1 to share. So I can't exceed that. So I can only pull 1x out of both terms. So then step 3 is I just multiply my answers from step 1 and step 2 together. So my overall GCF is going to be 5 times x. Which I could write as 5x. So the answer for number 3 is 5x. Okay, let's go back to number 1 now, which is finding the greatest common factor of 11w to the third and 8n to the fourth. I want you to try this one, realize that it's a little tricky, pause the video, and then restart after you've given it a try. Okay, so if we go through the steps, the first step is just to look at the numbers 11 and 8. And notice that the largest number that goes both into 11 and 8 evenly is 1. Okay, then if I look at the variable pieces, they don't have anything in common. This guy is all factors of w, this guy is all factors of n, so that means the GCF of the variable parts is also 1. So when I multiply those pieces together, my overall GCF is just going to be 1. Okay, now I want you to try number 4, which is this guy. Pause the video and then restart after you've given it a try. So number 4, if we go through the same reasoning, let's first look at the 20 and the 16. So if I look at those two numbers and I try to decide what's the largest number that goes into both, I think you're going to come up with an answer of 4. And then if I look at the variable pieces, well, this guy has 2 factors of a, this guy has 3 factors of a, so what that means is that they share 2 factors of a. They have 2 factors of a in common, so if I multiply my 2 factors of a times 4, I end up with 4a squared, and that's my answer.